everyone. You are watching IPM Leap, and in today's video we are going to discuss one of the most important question types. Questions based on this type have been asked repeatedly in entrance exams over the past few years, and if you have practiced them once with the right approach and the right understanding, there is no reason why you would not be able to solve them during exams. So the base question statement is, how many triangles with integral sides are possible? And this is the first question out of the three that we will be solving on this topic. These are question number 2 and 3, and let me tell you, all these questions have featured in previous year question papers. I am sure through these questions you will get ample practice on the topic and you will become comfortable with it. Let's discuss these one by one. Now, before we move on to the solution of both questions, here is the approach to solve them. There are various classifications of triangles based on their lengths of sides and interior angles. But two rules that apply to all kinds of triangles are: rule number 1, sum of any two sides of a triangle is always greater than the third side. And rule number 2 is, difference of any two sides of a triangle is always less than the third side. I am sure you already know these two rules. Apart from these rules, one classification of triangles that you should be aware of is that based on interior angles. Triangles may be acute, right-angled or obtuse. And we know in right-angled triangles, Pythagoras theorem applies, right? For obtuse angle triangles, the same Pythagoras theorem gets modified to x square plus y square is less than z square, where z is the longest side. Rest, I would just like to remind you that the tricky part is applying these rules properly. So let's learn how to do that. We will start with a question in which two of the sides are given and we need to count the possibilities for the third side. The question says, consider an obtuse angle triangle with sides 8 cm, 15 cm and x cm. If x is an integer, then how many such triangles exist? Let us try to see the range in which our third side can lie. Rule number 1 says sum of any two sides is greater than the third side, and is given that two of the sides are 8 and 15 cm. So 8 plus 15 is greater than the third side, which means the third side is less than 23. And rule number 2 says difference of any two sides is less than the third side. So if we take the difference of the two sides that are given, 15 and 8, then 15 minus 8 is less than the third side, which means the third side is greater than 7. So, for a moment, if we ignore that the triangle is obtuse, then the possible range in which our third side x can lie is 8 to 22. The count of numbers from 8 to 22 is 15. So, there were 15 integer values of x that were possible. This range of x tells us that either the longest side is 15 or else the longest side is x only. So let us fine-tune our possibilities for x because the given triangle is an obtuse angle triangle. We will get two cases. Case 1 is when 15 is the longest side. Have a look at this figure. This is what the case looks like. For an obtuse angle triangle, the sum of squares of two of its sides is less than the square of the longest side. So we get x square plus 8 square is less than 15 square. X square is less than 225 minus 64, which calculates to 161. Nearest square is 169 and 144. So 169 is the square of 13. Therefore, x should be less than 13 for sure. Within this overall range, we are down to 5 possibilities, as case 1 tells us that x can lie only in the range 8 to 12. The count of numbers in this range is 5. 8, 9, 10, 11 and 12. 5. Similarly, let's calculate our possibilities from case 2. Case 2, x is the longest side. Look at this figure. 15 square plus 8 square is less than x square. X square is greater than 225 plus 64, which is 289. This means x should be greater than 17. Again, within this overall range, x can take values from 18 to 22. The count of integers in this range is again 5. So case number 1 and case number 2 put together, we have 5 plus 5, that is 10 possibilities, and that's our answer for question number 1. Moving on to our question number 2. This question would be a cakewalk after question number 1. The question is, triangle ABC has integer sides x, y and z such that x into z is equal to 12. How many such triangles are possible if it is known that x is less than z? This question is simpler because in this question the given condition is xz is equal to 12. If we peg the value of x, the value of z automatically gets pegged to it. So let's draw down the list. X and z are integers. So starting with the smallest value of x is equal to 1, z has to be 12. Next, x can take value 2 and z has to be 6 in this case. And lastly, x can be equal to 3 and z is 4 in that case. To list down values of our third side y, we can use our two rules. Rule number 1 is, sum of any two sides of a triangle is greater than the third side. So, x plus z is greater than y. Rule number 2, difference of any two sides of a triangle is less than the third side, which means the difference of x and z is less than y. This is how we write it. So for x is equal to 1 and z is equal to 12, these rules translate into y less than 13, at the same time y is greater than 11, which means the only possible value y can take is 12. For x is equal to 2 and z is equal to 6, these rules translate into y less than 8 and y greater than 4, which means y can take values 5, 6 and 7. And the last case is, for x is equal to 3, z is equal to 4, rule number 1 gives us y less than 7 and rule number 2 gives us y greater than 1, which means y can take values 2, 3, 4, 5 and 6. There are a total of 9 possibilities, so option C is the correct answer. Let us take up our third and final question now. This question is slightly tricky because we need to ensure that we don't double count our cases. The question is, perimeter of a triangle with integral sides is equal to 15. How many such triangles are possible? Since none of the sides is given, we need to start with an assumption for the three sides. Let us suppose the sides are x, y and z, where x is the smallest and z is the largest one. So let's assume x is less than equal to y, which is less than equal to z. It's given in the question that the sum of sides, which means the perimeter, is 15. So we can write the equation x plus y plus z is equal to 15. Now I would say the question reduces to just a counting problem. We need to list down all possibilities and count them to get our answer. We have assumed x to be the smallest side. So the least integer value it can take is 1. On the other extreme, if x is equal to y is equal to z, if all three sides are equal, then x is equal to 5. So x can take values 1, 2, 3, 4 and 5. And we need to list down corresponding values of y and z now. See, my thought process is simple. Once you peg the value of one of the sides, say x, to calculate the possible value of other two sides, we follow our assumption that x is less than equal to y is less than equal to z. This assumption ensures that we don't double count our possibilities. And of course, we follow this given equation on perimeter. X plus y plus z is equal to 15. Let me show you how I count the possibilities. If x is equal to 1, using the perimeter equation, y plus z is equal to 14 and y is an integer value greater than equal to 1. But if we take y is equal to 1, from this equation we get z is equal to 13. In which case, sum of the two smaller sides x and y is much less than the third side z. So this combination won't form a triangle. We reject this possibility. Next value that y can take is 2, in which case z is equal to 12. Same problem, it won't result in a triangle. In this way, you can keep on increasing y and z decreases. This is because the sum of y and z is a constant. Next value that y can take is 3, in which case z is equal to z is equal to 11. Same problem. It won't result in a triangle. So I am sure you got a hang of what we are doing. Even if we take y is equal to 6, from this equation z calculates to 8. X plus y is still 7, which is less than 8. Triangle inequality does not hold. We reject this combination. It's only when you come to y is equal to 7, z also calculates to 7. In this case, x plus y is greater than z. So this is one possible triangle. Similarly, we need to count our options for other values of x. Watch the counting process play out on your screen. I'm sure you just need to understand and practice this question on your own once. With practice, you will be able to quickly jot down only the correct options. So the following are our possible triangles with integer sides. X is equal to 1, y is equal to 7, z is equal to 7. X is equal to 2, y is equal to 6, z is equal to 7. X is equal to 3, y is equal to 6, z is equal to 6, or y is equal to 5, z is equal to 7. Two triangles are possible. X is equal to 4, y is equal to 5, z is equal to 6, or y is equal to 4, z is equal to 7. Again, two triangles are possible for this value of x. And if x is equal to 5, then y is equal to 5 and z is equal to 5. This is the last possibility. So in total, we have 1, 2, 3, 4, 5, 6 and 7. 7 triangles possible such that the perimeter is 15 and sides take integer values. That brings us to an end of this very important maths concept. If you found the lesson useful, don't forget to press the like button and do share the knowledge with your friends and colleagues as well. Here is a glimpse of other popular maths videos on our channel. So keep watching and take care. Bye-bye.